This video is sponsored by LearnSQL.com. More about them later on. As a data analyst in business intelligence, you'll often be working with data that's contained in SQL databases. And often the data you need to build the dashboards you've been tasked to create lives across different tables in the database. In these cases, you'll need to write custom SQL queries to join this data together. In this video, I'll show you how it's done. Hello and welcome to Learn BI Online with me, Adam Finer, helping you do more with data. Now, this is part 2 of a 3-part series where we go step by step through building a data analyst project for your data analyst portfolio that, if you're looking for a job in business intelligence, will showcase your talents in working with SQL. Basically, in part 1, we set to work designing and building a relational SQL database for a fictional client who's opening a pizzeria. Since then, we've been collecting data thanks to everyone who's placed an order on the website. If you left your real email address when you ordered, you'll receive a copy of the data soon. For everyone else who wants to get hold of this data, I'll leave a link in the description. Whereas you don't necessarily need to have watched part 1 before watching this video, I'd probably recommend it to give you more context about the project we're building and what got us to this point. Also, you'll better understand the table structure and the fields in each table that I reference in this video. I'll add a card here and a link in the description to part 1 so you can start there before coming back to this video if you so desire. This video will help you practice writing complex SQL queries. If you're completely new to SQL or have relatively little experience of working with SQL, I'd recommend you start by watching my 3-part Learn Basic SQL in 15 Minutes series that I'll put a link to in the description. I'm also going to preface this video by saying that, although I've used SQL a lot over the years, I am not a SQL expert. If you're watching this and you are, it's very possible that you might do some of the things I teach in this video differently. If that's the case, please do let everyone know in the comments below. Okay, now we're going to look at the client's project brief and write SQL queries to create the views of the database we need to build the dashboards the client wants. We're going to start with the orders data, and here's a quick reminder of the tables we built. We have tables for menu items, orders, customers, and delivery addresses. If we look at the brief, we can see a list of the queries we'll need to build a view for. Total orders, total sales, total items sold, average order value, sales by category, top selling items, orders by hour, sales by hour, orders by address in a map, and orders by delivery method. Here in the orders table, we've got row ID, order ID, created at, item ID, quantity, customer ID, delivery method, and address ID. So we're going to need to join the item data and the address data to the orders data. Let's get started. Here in NAVICAT, I'm going to create a new query and start selecting the columns I need. Select, return. The first query is total orders. For this, we'll need the order ID column so that we can count them. Now, because we'll be joining data from different tables in the database, to simplify the query syntax, I'm going to be using table aliases. So let's start with O for orders, dot order underscore ID. Next, the brief asks for the total sales, for which we'll need the item price column from the item table. So we can sum up all of the values. I for item dot item underscore price. For total items sold, we'll need the quantity column. O dot quantity. To get an average order value, we can simply divide total sales by total orders. That we can do in our BI tool, so no need for any calculations in our query here. Next up is sales by category, so we'll want to add I.item underscore cat. Number 6, top selling items. For this, we'll need I.item underscore name. Numbers 7 and 8, orders and sales by hour, are going to need O.created underscore at, which contains a timestamp. For 9, orders by address, I'm going to add all of the address fields, so a.delivery_address1, a.delivery_address2, a.delivery_city, and a.delivery_zip code. And finally, for query 10, from the orders table, we'll need the o.delivery column. Okay, so those are the columns we need, and now we just have to specify how to join these three tables, item and address, to orders. First up, we type from orders, followed by its alias, O, as the table will join the others too. Then we're using a left join to the item table, I, on the joining condition o.itemid equals i.itemid. For those of you who are unfamiliar with SQL joins, I'll put a link in the description to another of my videos that breaks them down for you. But you can still carry on with this video and watch that one after if you like. Let's keep going. So we've joined the item table to orders, and now we'll do the same to the address table. I'm just going to copy and paste this row and change it to the address table on o.add_id equals a.add_id. And that's it. We run the query and we can see the result. It contains all of the columns we'll need for our first dashboard. Before we move on to the next part of the project brief, more about the sponsor of today's video, LearnSQL.com. If you want to learn or practice SQL, check out LearnSQL.com. They have a set of over 50 hands-on SQL courses. This unique platform offers a 100% online experience with nothing to install. Everything happens through your favourite web browser. All of the courses are interactive and based on real-life business scenarios, meaning you'll be writing SQL queries and seeing the results instantly. Do you want to become a data analyst or encourage your company to be more data-driven? LearnSQL.com is the place to go. You'll find a link to LearnSQL.com in the description below for you to check out their offer and choose one of their learning paths in SQL, PostgreSQL, or T-SQL. With LearnSQL.com, learning SQL has never been easier. Okay, so the next part of the brief relates to inventory and stock levels. If we look at the client brief, we can see the requirements in terms of data. Total quantity by ingredient, total cost of ingredients, calculated cost of each pizza, and percentage stock remaining by ingredient. We're going to need to create two different views of the data in order to give us the result we'll need for all of the queries we have to include in the dashboard. You'll see why as we go through. In fact, this is something that you need to bear in mind when you're doing this kind of work. You ideally want to have as few views, i.e. different data sources, as possible to work with in your BI tool. But sometimes you'll actually be better off not trying to twist your data into knots to try and get the desired result, when you could actually create more than one view that will give you the same result and won't adversely affect the way you need to build your dashboards. The trick is to identify which approach to take, and this comes with practice. Okay, so let's start off with working out how to produce a SQL result that will give us total quantity by ingredient. To calculate this, we'll need to know how many orders there were and what the recipe is for each pizza. We can then multiply one by the other to get the total quantity, or weight. First, what I'm going to do is to create order quantity per pizza, and for this I'll need the orders table and the item table that contains all of the menu items and their names. Again, I'm going to use table aliases, so select o.itemid, i.skew, i.itemname. Then we'll need to aggregate the quantity column, so sum o.quantity in parentheses as order quantity from orders alias o. We'll then left join from the item table I on the joining key o.itemid equals i.itemid. Then we'll use the group by for our aggregation o.itemid, i.skew, i.itemname. If we run that, we get what we need, or at least the first step of what we need, the number of orders per pizza. But now we'll need to break down these pizzas by ingredients. That comes from the recipe table. So we'll need to join to this next. Left join recipe r on i.skew equals r.recipe id. And the columns we want to include in the result are r.ing id and r.quantity as recipe quantity. Because we've added these columns to the result, we'll also need to add them to the group by. When we run that, we can see the breakdown by ingredient ID as well now. But we're going to need the ingredient name, and that comes from the ingredient table, which means, you guessed it, we'll need to join that as well. Left join ingredient, ing, on ing.ing id equals r.ing id. And we'll add the ing name column to the result, and therefore the group by. We're looking good so far. We can now calculate the total quantity of ingredients using this result. The next thing we need to do is to calculate the total cost of ingredients. We already have the quantity, so if we can get a unit cost for each ingredient, we can then multiply this by the number of units, i.e. the quantity or weight. We've actually already got access to this data because it's in the ingredient table that we've already joined. We just now need to include the columns which are ing.ing weight and ing.ing price. Let's not forget that we also need to add them to the group by. Now, at this point, one of the things I'm going to need to do is to multiply order quantity by recipe quantity. But the problem we have is that order quantity is already an aggregated field. This means I can't use it in the calculation we need in the same select statement. So how do we do it then? Well, the answer lies in what are called sub-queries. Let me show you how this works. I'm going to put this whole query in between parentheses. Before the open parenthesis, I'm going to type select star from. And after the closed parenthesis, I'm going to give this whole query an alias of S1. Now, if I run this query, I get exactly the same result as we had before. But now I can specify the columns I want from the S1 query and result and do anything to them as if they were in a regular table. Like, for instance, using them in calculations. Just what we're looking to do. This will also give us a chance to select just the columns we're interested in to make our result as tidy as possible. The other columns will remain available to specify at a later date if we so desire. I want s1.itemName, s1.ingID, s1.ingname, s1.ingWeight, s1.ingPrice, s1.orderQuantity, s1.recipeQuantity. And then we want to calculate order quantity multiplied by recipe quantity as, I'm going to call this ordered weight. For cost per unit, it'll be the ing price divided by ing weight as unit cost. Finally, we want to calculate the unit cost multiplied by the ordered weight to get the ingredient cost. So we'll just copy and paste those two calculations here and call it ingredient cost. If we wanted to, we could actually remove the columns that we don't need, like ing weight and ing price, because we don't really need them. But they're not doing us any harm, so I'm just going to leave them in. This is great. We now have all we need to not only calculate cost of ingredients, but also the cost to make each pizza, which is point 3 in the brief. For the remaining 2 points, percentage stock remaining by ingredient and list of ingredients to reorder based on remaining stock levels, we're going to need to create another query to give us what we need. But it'll be based on the work we've already done. We're going to want to take the result we've just created with our custom SQL query and manipulate it some more. To make this job easier, I'm actually going to turn our custom SQL query into a new view. But I hear you saying, I thought what we've done so far was a view. Well, in fact, no. We've been writing what are called ad hoc custom queries. What's the difference? The short answer is not a lot, at least in terms of what our use case is and the data model we're working with. As far as I can gather, and I am no SQL expert, there is relatively little difference in terms of query performance, and they both work in almost identical ways. If you do really want to know what the difference is, please feel free to investigate for yourself, but that's as far as I'm going to go. In NAVICAT, I'm simply going to select all and copy the query. Then New View, paste and save as stock 1. Going forward, if we want to work with the data in this view, I can just refer to it as stock 1 as I would a table, like you see here in this new query. Now I want to calculate A, the total weight ordered, B, the amount of inventory, and C, the amount remaining for each ingredient. The first step is to aggregate the ordered weight for each ingredient that we can do by selecting ing name and summing ordered weight as ordered weight. Of course, we need the group by with our aggregate function, so group by ing name. And there we have the start of our new desired result. What we need now is the total weight of inventory for each ingredient we started with. For this, I'm going to join the inventory table. And for this, we'll actually need to include the ing ID column because it'll be our joining key. I'm going to turn this query into a subquery like we did before and call it S2. Now let's left join the inventory table to it, like so. We can see in the result that now we have the quantity for each ingredient in stock. But we also need to add in the total weight in stock from the ingredients table. That will be the quantity times by the weight that each ingredient is bought in, like so. In fact, we could actually take out these two columns and just leave the calculation. Perfect. The last piece of this particular puzzle is to calculate total inventory weight minus the ordered weight as remaining weight. And we're done. That is everything we need for the stock part of the brief. Before moving on to the last part of the project, let's just take a quick pause. If you're fairly new to SQL, this will probably all be quite overwhelming in terms of the information I'm sharing. Don't worry, that's totally normal. The great thing is, this is a video, which means you can pause, rewind and rewatch as much as you need to. Why not hit the like button now so that this video gets saved to your liked videos playlist and you know where to find it. And if you plan on following along with part 3 of the series, please subscribe to the channel and hit that notification bell so that you don't miss it. The last thing I'll say is that if you want to get your hands on the CSV data for all tables, as well as a SQL dump file for you to be able to recreate the database wherever you like, plus all of the queries you see in this video, I'll put a link in the description. And if you're someone who placed a pizza order and contributed to this data, you'll be getting a free copy of the CSV files mailed to you shortly. Okay, let's jump back in and finish the last query we'll need for the staff part of the brief. So, if you remember from part 1, we have 3 separate tables for the staff part: staff, rota, and shift. We want to start with the rota table because this contains the date. So we'll select r.date because we'll give the rota table an alias of r. Then I'd like the first and last names of the staff members. Using the alias s for staff, I'll specify s.firstname and s.lastname. I'm also going to need their hourly rate for our calculations, s.hourly rate. Now we want to join the staff table to the rota table, so left join staff on, the joining key is r.staffid equals s.staffid. If I run that, we can see it gives us the result we need. Next up, I'd like to include data from the shift table as well. specifically the start and end times of each shift. So with an alias of sh, I'll type sh.starttime and sh.endtime. In order to join this data, I'm simply going to copy and paste the previous join we just made and modify it to be shift, sh instead of s, and r.shiftid equals sh.shiftid. Great, we're almost there. The final thing we'll need to do is to calculate the staff cost per row. This will essentially involve calculating the number of hours in each shift and multiplying this by the hourly rate. Sounds simple, but it's actually not as simple as that. At least the way I do it isn't that simple. If you're watching this and you know a better way, please do let me know in the comments below. I'm going to be using the timediff function, turning the result into a total number of minutes, and then dividing this by 60 to get a number of hours as a decimal, to then be multiplied by our hourly rate. Here it is, and I'm simply going to walk you through it. So the first part asks for the difference in hours between the start hour and the end hour, which is then multiplied by 60 to turn it into a number of minutes. Then I add to this the difference between the start and end minutes. This gives us a total minutes that I then divide by 60 to get the decimal hours. We can see in the result that this is giving us the correct calculation. In order to get the staff cost for each row, I just need to copy and paste this row and multiply it by s.hourly rate. And voila! We'll now be able to sum up all of our staff costs and hours worked for any given period and break that down by staff member. So in part 3, we'll be connecting this data to our BI tool and building the dashboards the client has asked for. If you found this video useful, please do give it a thumbs up and subscribe if you haven't already. Again, if you'd like to get your hands on the CSV data, the SQL dump file, and the queries we created during this video, click here. Thanks so much for watching, and I'll see you soon for another video. Until then, stay BI curious.